How's it going, everyone? Welcome back to another video. Today we're going to be looking at more multiple choice questions from the grade 12 March exams. Question 1.1, a 4-mile group is the functional group of what? So this one, just a recall question. We need to know, we need to remember 4-mile goes with aldehydes. Okay, question 1.2, the number of carbon atoms in an alkyne with 14 hydrogen atoms is what? Okay, so let's refresh our memory here. Alkynes have the general formula CnH2n-2. Now, we've been given the number of hydrogens, so we can say that number of hydrogens equals 14. The number of hydrogens is 2n-2, so 2n-2 equals 14. We solve for n now. We're going to get 2n equals 16 and then n equals 8. So the answer is B also. Question 1.3. Which one of the following arranges the organic compounds in order of increasing vapor pressure? Okay, so increasing vapor pressure means decreasing boiling point. Remember, vapor pressure and boiling point are opposite each other. All right, let's look at these molecules or compounds. We have methyl butane, dimethyl propane, and pentane. Okay, so from the looks of this, it looks like they are changing the branches here, because pentane has 5 carbons. Dimethyl propane. Propane we know has 3 carbons, and dimethyl means there's 2 methyl branches, and a methyl branch has 1 carbon. So that's going to be 2 carbons plus 3 carbons, that's going to be 5 carbons. And then likewise for methyl butane, butane has 4 carbons, and a methyl group on it is going to add 1 carbon. So we're going to have 5 carbons here. So all these molecules, all these compounds have 5 carbons, but it's the number of branches that change. So we need to remind ourselves what happens as you add branches. So as you add branches, the surface area decreases, right? If the surface area decreases, it means that the intermolecular force is going to decrease. And it means that the boiling point will then decrease. So simply put, more branches means a lower boiling point. So we need to ask ourselves now, from these molecules, which one has the most branches? Dimethyl propane will have the most branches. It's going to have 2 methyl branches. So that should be last. Okay, so the answer here would be C. Increasing vapor pressure, decreasing boiling point. Dimethyl propane has the smallest surface area, and since it has the smallest surface area, it's going to have the smallest intermolecular force, the weakest intermolecular force, and it's therefore going to have the lowest boiling point. Whereas pentane, on the other hand, pentane has it has no branches. It's going to have the strongest intermolecular force, and so will have the greatest boiling point. Okay, right, so let's move on. Question 1.4. Which one of the following will decolorize orange bromine water rapidly? So this is something referred to as a bromine test, right? And it is a bromine test for saturation, right? So basically what happens is, if you have an alkene and an alkane, right? We know that an alkane is saturated, and we know that an alkene is unsaturated, right? If we have bromine in them, if you have bromine and bromine, in the alkene, a reaction will occur. right? And the reaction is going to cause a color change, right? So the color will change from red to clear, right? And that's because of the reaction of the bromine with the alkene. So we need to ask ourselves here, which one is an alkene? A is not an alkene. B is not an alkene. C, this follows CnH2n plus 2. That is an alkane. That means D is our answer. Okay, let's move on. Question 1.5. The general reaction of alkanes with halogens can be represented by the following general equation. Okay, so we have an alkane here, and you have a halogen. So basically what's happening is one halogen is switching places with one hydrogen, right? You can see here, there's one hydrogen less, but there's also a halogen that's been attached. So this is an example of a substitution reaction, right? You could also remember it like this, an alkane, and this is becoming a haloalkane. So this is an example of a one-to-one reaction. One-to-one meaning all single bonds going to all single bonds again. That's obviously going to be a substitution reaction. Question 1.6. A functional group or functional isomer of butyl ethanoate. Okay, so butyl ethanoate, that is an ester. Right, so the functional isomer of an ester is a carboxylic acid. Right, so we need to check which one is a carboxylic acid. A and B are carboxylic acids. So C and D are out. But now we need to check from A and B which one is going to be the most correct. 2-methyl pentanoic acid or 2-methyl hexanoic acid. So to answer this, we need to look at our ester. Our ester is butyl ethanoate. Butyl means it has 4 carbons. Ethanoate means it has 2 carbons, right? Butane, ethane, 4 and 2. So total 6 carbons. So remember, for an isomer, the number of carbons and hydrogens and oxygens will all stay the same, right? So let's look at the first one, A, methyl pentanoic acid. So 2-methyl pentanoic acid. This methyl means 1 carbon. Pentanoic acid means 5 carbons. So that's a total of 6 carbons. So this is looking more likely to be the answer. Let's make sure. So B is 2-methyl hexanoic acid. That's 1 carbon. That's 6 carbons. That's a total of 7 carbons. We can't increase the number of carbons. Remember, this is an isomer. So the answer is A. Okay, let's move on now. We are moving on to the physics part. Question 1.7, a constant net force applied to block P causes it to accelerate at 5 meters per second. The same net force applied to block Q causes an acceleration of 2.5 meters per second. What is the ratio of the masses? Okay, so there's a lot of ways to do it here, but I'm going to show you what I feel would be the easiest way, which is just substitute and test. Okay, so what we'll do here is we'll separate this, right? We'll have block P and then we'll have block Q. And we're going to say F net equals MA, and then here F net equals MA. Now, easiest way I feel, let's just substitute a value. Let's make F net 5. Right? Let's make F net 5. You could choose any value, doesn't really matter, but I'm choosing 5. So 5 and then here 5. Remember, they tell us the F net is the same. Okay? Now let's look at the acceleration. So the acceleration for P is 5. The acceleration for Q is 2.5. Now let's look at what values the masses will need to be for these equations to work out. So 5 times something will give me 5. So the mass for P needs to be 1. Right? And then for Q, the mass for Q will need to be 2. So if I look at the ratio of the masses, So the mass of P divided by the mass of Q, here we got 1 over 2, or you could say 1 to 2. Now, no matter what values you've chosen, if you divide them, you still should get a simplified version of 1 to 2. So the answer here is A. Let's move on. Question 1.8. An elevator lift suspended by a cable moving upward and slowing to a stop. Okay, so this one is important. Slowing to a stop. So even though it's moving upward, right? Even though it's moving upward, right? The acceleration is downward because it's slowing down. So it's important that you understand that and just kind of also just remember it. If you are slowing down, it means that your acceleration is in the opposite direction. You have a negative acceleration. So you're moving upward, your acceleration is downward. And then we can look at F net equal MA, right? If you have to have an acceleration that's downward, it means that Fg minus the tension is going to equal to MA, right? If you have to draw a free body diagram here, Fg minus tension is going to equal MA because A is greater, right? And if you want to think of it in terms of a force diagram, these two values, in order for it to work, gravity needs to be, the Fg needs to be greater than the tension, right? Fg is going to be greater than the tension. If tension was greater than Fg, then it's going to be accelerating upward. Okay, so the answer here has got to be C. The diagrams are a bit difficult to distinguish here. I'm going with C because it appears that Fg is bigger than T. Okay, let's move on here. Question 1.9. A ball dropped from rest elastically collides with the ground and bounces once. Take the point of release as 0 position. Important. Okay. Neglect the effects of air resistance. Okay. Which one of the following position time graphs below correctly represents the motion of the ball? Okay. So immediately, right, we need to cancel A and D. Because remember, for vertical projectile motion, right, acceleration is going to be in play. Acceleration is going to be 9,8, right? And what is acceleration? Acceleration is the rate of change in velocity, right? If you look at A, these are straight lines, right? And this means a constant velocity. If an object is moving, if it's falling and gravity is pulling it down, that means it's accelerating. It means the velocity is changing. So we don't necessarily draw straight lines for position time graphs in VPM. Because remember, the velocity is always changing because there is acceleration present. So A and D would be out. All right, so now we're left with B and C. Now let's consider for a moment. Let's just draw a diagram here and maybe it'll help us. So say we have this object, we have this ball, and this is my 0. Right, that's my 0. Okay, let's just write there 0. As this object goes down, right, its displacement or its position is going further away from 0, right? I mean, it could be 20. It could be minus 20. It doesn't matter in this case because it's they don't tell us which direction is positive. But the idea here is that it's moving away from 0. Right? So as that object is going down, it's moving away from 0. Okay? So if you look at graph B and C, since they tell us take the point of release as 0, if you look at B, the object starts at 0 and the graph is moving away from 0 until it hits the ground. And then it returns back. So B is looking more likely. Let's look at C. So C, the object is starting from some position and it's moving towards 0, right? And if the point of release is 0, It means that as time passes, we just saw here, as time passes, the ball is moving away from that 0 position. So that's why B should be the correct answer. And the last one, if an object has a velocity x and kinetic energy y, then its momentum is given by what? Okay, so we'll write here that momentum is equal to mv, and then we know ek is equal to half mv squared. So now they tell us that the velocity is x and the kinetic energy is y. So y equals half mx squared, and then here we can say p equals mx. All right, now let's try to make this resemble that. So how can we do that? So we can say, so if we start with our equation, p equals mx. So if I half both sides and then multiply by x, then this will be half px equals half mx squared. Now half mx squared is y, right? So half px equals y. Now they want us to solve for the momentum. So they want us to solve for that. So we can say that half px equals y over x, and then, half p equals y over x, and you take the half across, you're going to get p equals 2y over x. So the answer there is C. All right, that's it. If you like this video, please consider leaving a like. If you want me to do something specific or a specific question from a specific paper, please leave it down in the comment section below.